Alright, it's time to do a little solving exponential and log equations. And it's going to be quite a blast, let me tell you what. So here we have some exponentials with the same base, meaning we've got 5 and 5. Those are our bases. They're the same. Well, if our bases are the same, shouldn't our exponents also be the same if we are saying that they are equal to each other? And you are absolutely right. So I can just take the exponent, 6x minus 1 equals 11, and now I've got 6x equals 12, x equals 2. Nice. And if I plug that back in to check my work, because I love to check my work, I've got 6 times 2, which is 12, minus 1 is 11, so 5 to the 11th equals 5 to the 11th. Sounds pretty equal to me. Nice. So this next one, we got a 64 equals 8 to the 6x minus 4. We were just talking about like setting exponents equal, but like what the heck's going on here? Because really we just have 64 to the first, but my bases aren't the same. What could I possibly do? What if I wrote 64 as 8 to the second, right? Because 8 squared is 64, I know that. And now I have that equals 6x minus 4. Okay, well, 8 to the 6x minus 4. Now I have the right bases here. I've got the same bases, so I can take my exponents and I can set them equal because, you know, that's just so much fun to do, and now I can solve a new equation, just like we did before. I just had to manipulate a few things first. So I can add the 4 and I get 6 equals 6x, so I know that x equals 1. And I do like to plug these back in just to make sure everything's ship-shape. So I would have 6x, so 6 times 1 is 6, minus 4 is 2, 8 squared, that equals 64. It works in the original, we good. But how about this next one? Holy cow. We got a whole thing going here. We have 3 to the 2x minus 6, and we've got 9 to the 2x. We've got different bases. Maybe we can use, pull a play from the last one. Alrighty, so I know I can write 9 as 3 squared, but I've also got that raised to the 2x. So that's going to stay out there. I just rewrote 9. I rewrote my 9 as my 3 squared. So now what I'm also going to have on this right-hand side is I would take the 2x and multiply it in, because those are my exponent properties. If I have an exponent to an exponent, I multiply it in. So I've got 3 raised to the 4x. And that's going to equal 3 to the 2x minus 6. And once again, I can just set my exponents equal to each other now that they have the same base. So I've got 2x minus 6 equals 4x. I'm going to subtract the 2x, so I get negative 6 equals 2x. So x equals negative 3 once I divide by 2. Now I can plug this into the original. If I had negative 3, I'm going to have 2 times negative 3 is negative 6 minus 6 is negative 12. So I have 3 to the negative 12, and I would have 9 to the negative 6. If you were to plug that in your calculator, you would see they are the same. Now negative numbers are okay with exponents. Once we get into solving logs, negative numbers are a no-no in certain situations, but we'll talk about that in a bit.